Well, hi there, and thanks so much for showing up for your math learning today, everyone. I remain your humble math servant, Mr. Jennings, and today we're reviewing using tables and graphs in order to represent the relationship between two things. We've just looked at an example looking at time versus money, and we saw on a graph we can show how time does equal money. At this point, let's take a look at some more abstract, more just totally algebra-based examples. If I have this relation y equals minus 2x plus 5, and I would like to see this relationship on the xy plane so that I can visualize as the x number changes, how is the y number changing? Okay. One of the ways I can do that is just by filling in a table. So, in order to do that, I'm just going to choose, and I get to choose some of these values. They can be totally made up. You get to make that choice of, am I going to look at x as minus 2, minus 1, or in this case 4? I like to look at some points that are a little more spread out so I can get a little more accurate graph, but it's entirely up to you. So in order to fill in a table, first we're going to just use this as a substitution exercise. Y is equal to minus 2 multiplied by x. But in this case, I'm interested in this number minus 2, when x is minus 2. And then I go ahead and finish my equation, plus 5. And now, all that's left is to evaluate what's the value of y when x is 2. You see here, x is minus 2. So let's go ahead. Y is equal to minus 2 times minus 2. Positive or negative 4? It's two negatives, so is it super negative? It is positive. It can only be positive or negative. There is no super negative, so that is 4. 4 plus 5 is 9, so we can go ahead and put 9 there. And then once we've got that, that's an ordered pair of values. When x is minus 2, y is 9, so let's go ahead and put that onto our graph. We find the x value first, and then go up to find the y value, and there's that point there. If we want a super spicy graph, we're going to go ahead and label that point, minus 2, 9. And then, here's a little trick. Rather than, one thing that we could do is, and I'll do this here and then I'll show you the trick in a second, is just go ahead and write out the equation again. Minus 2 times this time minus 1. Put in minus 1 for x, and add 5. So then we get minus 2 times minus 1 is 2 plus 5, and 2 plus 5 is 7 every day of the week. So we go ahead and find minus 1 and 7 and put that on the graph. And then if you're someone like me who likes to save a little bit of work, you can go ahead and just erase that little pencil mark where you put in the x and put in the next value of x that you're looking at. Minus 2 times 0 is 0. Everything times 0 is 0. So we have y is equal to 5 in this case. We go ahead and find, 0 on the x-axis and 5 on the y-axis and put that point there. If I want, I can label that point 0, 5. These are how we label the points. Already I can see that this equation is forming a line. And I can confirm that by going ahead and substituting in some more values. If I put in 1 there, minus 2 times 1 is minus 2 plus 5. Minus 2 plus 5 is going to give us 3. So I can find that point 1, 3 and put that on there. And I can label it as well. 1, 3. Okay, and then one more. Let's take a look all the way down there at 4. There's no reason that I have to go same increment by same increment all the time. I can go ahead and put in 4 into this equation. Minus 2 times 4 is minus 8 plus 5. Well, a negative 8 degree day that gets 5 degrees warmer is minus 3. So then we go ahead and find 4 in the x and minus 3 in the y. And wouldn't you know, this thing just goes over and down, over and down, over and down, making this straight line. Off to infinity in that direction, and off to infinity in that direction. Any other shortcuts that I could have used? Does anyone know any shortcuts to graph something like that? Bypassing the table.
We define the slope.
Sure. So some number in that equation is the slope or the rate of change. Which one is it?
A -2.
-2, okay, cool. And then what does that 5 mean? What is that 5 doing to the equation?
It's like where it starts off on the y-axis.
Very good. So here is the y-intercept, 0, 5. And so that point there is always, in a linear equation, going to be 0 and then the b value. We're looking at a y equals mx plus b, and that's where you're going to find it. If I want to explore that a little bit more, what I can do, oh, there I am. What I can do is look at that on Desmos. And so if I look at that on Desmos, if I say y equals mx plus b, and I put in my sliders, here's an m value of, well, we had an m value of -2, so that's going to look like this. And all y'all are going to spend a lot of time investigating things in Desmos. It's a great place to look at relations and functions, and building your intuition for these things. If I raise that b value up to 5, I'll see I get something that matches our graph quite perfectly. There's the intercept, 0, 5, and then the m value of -2, well, that's showing up in the slopiness of the line. Here's your double black diamond, here's your green circle, and then I'm noticing negative values and the line go down as we go forward. As x gets bigger, y gets smaller. If it's negative value, as x gets bigger, y gets bigger, positive value. All right, so now going back to our graphs here. Now, what if we wanted to graph negative x squared minus 2x plus 5 on the same axes here? I wonder what that's going to look like. Negative x squared minus 2x plus 5. The last one made a line. What type of shape is this one going to make? Down here, negative x squared minus 2x minus 5. In this course, we're going to see a lot of new algebraic formations. This one actually comes from grade 10. You will have seen these types of shapes before. But this year, we're going to, you got it. This year, we're going to see a lot of new ones. So a great way to see, hey, what is this math machine doing, is to prepare a table of values and graph it. Or just type it into Desmos and see. Okay, so let's take a look. We are going to take this math machine and feed it these values. -2, -1, 1, and 4. Same values that we had before. Let's see. So if we go for y equals, let's try -2. Negative. Oh, what is that bracket doing there? Why did Mr. Jennings put the -2 in brackets in both places? Arusha, do you know why I use brackets when I substitute in there? Well, let's take a look at what it would look like if I didn't use brackets. It would look like this. Y is equal to -2 squared -2 -2 plus 5. Are these the same things? This is a mess. Do you agree? I'm not sure. Am I that looks like I'm subtracting -2 from -2, but here it's multiply, please, not subtract. So that's one place where the brackets inform your orders of operations and tell you what operation to do. This is one of the reasons why you always substitute into brackets. Another reason is -2 squared the same thing as in brackets, -2 squared? Are those the same? Arusha, you're smiling. Do you know the trap here? You can pass. You can elbow someone on your side and say, hey, you answer this question. Yeah, so are these the same or different? They're different. Yeah, well, one is this one here. These are not the same. Okay, and that's critical to understand. So here, this one is like saying, please take -2 and multiply -2 by itself. What's -2 times -2? 4. People are just saying 4, and I assume they mean positive 4. But over here, -2 squared, this is the same thing as saying, take 2 copies of 2 and multiply them and make the answer negative. Only the 2 is squared in this case, not the negative sign. So that's one place where students will make a lot of errors, and you just want to be clear. It's how we write things down, and that makes the math work. It's not a math rule, it's a writing things down rule. Okay? So over here, this is -4, And I think you'll agree you would wear different clothes on a 4-degree day than a negative 4-degree day. A 4-degree day and probably a toque is optional. A negative 4-degree day and you probably feel like you really want one to make it to school. So that was a long sidebar, but an important one to help you avoid some of those errors. Always substitute into brackets and understand what we mean when we have like something squared like that. Okay, squared just means multiply by itself. Okay, so now we evaluate. So I have y is equal to negative the result of negative 2 squared, and negative 2 all squared is 4. So we have a positive 4 in there. But we're going to make a negative in a second. Negative 2 times negative 2 plus 4. And then 5. Well, that's just 5. What's minus 4 plus 4? 0. 0 plus 5? 5. Lovely. So we're filling in our table. Now let's go ahead and we're going to put that onto our graph. Minus 2, 5. Remember, these are alphabetical. Students will sometimes be confused. Wait, which one is first, the x or the y? X is first, y is second, because it's just like your ABCs. And if you forget, just sing the song until you get to x, and you'll feel, oh, I found x before I found y. Alphabetical. Okay. Next, we can go ahead and substitute in minus 1. So I'm going to go ahead and remove these. You and me both. Okay. And I'm going to put in minus 1 here for x. I like skipping a little bit of work, so I just... all this is rough work, right? The table is what I'm interested in. So get the table right. And then check it in Desmos later to make sure you did it right. So minus 1 squared, that's 1. So I have 1 inside that bracket there. Minus 1 times minus 1 is positive 1. But then I make it negative because the equation said to do that. Minus 2 times minus 1, plus 2. So minus 1 plus 2 plus 5, 6. All right. Well, let's keep going. Okay, next, let's take a look at 0. So I'm going to put 0 in there for x. And 0. Okay. So what's 0 squared? What's negative 2 times 0? 0. 0 times anything is 0. So 0 squared, 0 cubed, 0 to the power 100 is just 100 zeros multiplying each other. So it's still 0. So we have y equals 5 again. So we go ahead and we put these points on our graph. Oh, I forgot one. But there's the point 0, 5. Here is the point negative 1, 6. And I'm seeing that we're already starting this beautiful parabola shape. I wonder what happens as we go out that way. So then I'm interested in 1 and 4. So we go ahead and sub those in, nice and quick. So here we have minus 1 minus 2 plus 5. That gives us 2. Minus 1 minus 2 plus 5. Basically like 5 minus 3. And then let's check what's happening when we do 4. What's 4 squared? Okay, so I have minus 16 there. The minus is because we're starting with that leading negative, right? It says square 4 and make it negative. And then minus 2 times 4 is minus 8. So minus 16 minus 8 plus 5, where are we? A negative 16 degree day that gets 8 degrees colder before getting 5 degrees warmer. It's very cold. How cold is it now?
19.
Negative 19, very good. So we are now down at negative 19. Oh no, I don't have negative 19 on my graph. So I know that this is way down there. Look, that's minus 8, then this point is like somewhere down here. You can still extend your thinking, your visualization off the edges of graphs. That's still okay. So now I'm noticing that, oh, and I had 1, 2. So let's put the point 1, 2 on there. It's like this. So this is what our parabola is going to look like. We found the vertex. It's here, and it's symmetrical around that vertex. So it goes there. And if I'm interested, what's its value at -4? I can substitute in and find that it's at -3 there. And then over here it would be at -10. And then at -19. So this is going to be what our graph looks like. And it goes off in that direction and that direction to infinity. Well, negative infinity in both cases. Okay, so now allow me to point out something that may be useful to you for visualizing these parabolas in the future. Did you notice that I kind of had us use this piece twice? This -2x plus 5. See what I'm talking about? Here's -2x plus 5. We graphed it. It made a line. When we did negative x squared minus 2x minus 5, it's no longer a line. The presence of that x squared bends it away from the line negative 2x plus 5. See that there? So I'll show you a Desmos visualization of this in a second, but can anyone describe the relationship between that parabola and that line visually, particularly about what's happening at the y-intercept? What do you notice along here and with this parabola here? Sydney?
The intercept at the same point of the y-intercept?
Yeah. So when you look at a parabola in standard form, these parabolas where we have some x squared plus some x plus some number are called standard form. Ax squared plus bx plus c. The bx plus c is a line if we take away the ax squared. And the bx plus c is a huge clue about how the parabola is going to look. They share the same y-intercept. Do you notice something else they share as they cross the y-axis? Does the parabola pass the line, or does it just kind of kiss it and then peel away on both sides? So it just kisses and then moves away. So this is called a tangent line, where just like you can imagine a bike tire kissing the ground. So that's it's a mathematical term, kissing. Okay, it means for two curves to just touch without crossing. So your bike tire sits on the ground. It's a tangent. It only touches the wheel at one point. The parabola is like a bike tire in that its slope is always changing. It's a curve. But at any point, it has a slope at that instant. And the instant that it's crossing the y-axis, it has the same slope as that line that's in the equation. So once you can visualize that line, knowing mx plus b, you can also visualize your parabola, just coming up and kissing that line. So the main thing that we looked at today is whenever you see a math machine, like one of these functions, you can create a table of values, choosing x values yourself to find those points on the plane and then plot those points. So continuing on, go ahead and try some of these examples and see how some of the numbers are changing things. Try some of these lines that have non-integer slopes. I've given you some tables of values that you can use to plot those. And try some of these parabolas as well. Any questions? Come get me. And I will be moving around viewing your beautiful graphing, everyone. And thanks so much for showing up for your math learning today. Oh, wait, it's over here. Everything's new.